To start with, we will be talking about how to design a lakehouse, not for the data engineers, but for the product engineers. Before that, I'm Joe. I'm a co-founder CEO of Mooncake Labs. Before that, I spent almost a decade working on HTAP, high-performance databases in single store. So let's start. First thing we'll be asking is, let's ask some product engineer. What kind of lakehouse do you want? Or do you want a lakehouse? What's the features you like? And if you try it, the only answer you will be getting is, I don't care. Every product engineer will give that answer. It will be, I don't know, I don't care. Okay, that's it. Thanks for attending us. There's no point to continue. Okay, just kidding. The lakehouse now is actually the opinion is very divided. On the left side, we're saying what the data people, what us are saying. The lakehouse will be the OLAP database archetype for next 10 years. It's I believe in that, you believe in that. The giants Andy Pavlov, Michael Stoneberger, in their papers, all believe in that. Why? Because lakehouse comparing to traditional data warehouses, it's cheaper, it's more scalable, there's no vendor locking. And comparing to the traditional data lakes, it's you actually get full table semantics with iceberg or delta, and you can actually get good enough performance. But on top of that, it's actually more flexible now, so people can have different engines, either single box or distributed engines, and use both SQL and Python to query them. All the data engineer, data scientists love that. Well, what's on the other side? When I talk to our friends at all these product companies, this is what they will hear back. First is I don't understand what a lakehouse is. I kind of understand they kind of understand what a data warehouse is. You can just store, put a lot of data there in tables, and then run queries is fast enough. And the next part, when you explain what a lakehouse is, the next question they will get is, I cannot get an iceberg table. And then if they somehow were able to try or get a lakehouse table, the next thing they will say is I'm building an application, but with this complex infra, my app is actually not getting better. At the end of the day, they will come to the conclusion, the lakehouse is just for big data people. I really don't get it. I'm hearing it many, many times. So what do product engineers really want? We kind of believe today's app becoming more intelligent. So it actually have more and more data needs. The traditional crude applications probably won't exist anymore, or there won't be the mainstream. Today's applications, the transactional side is mostly handled by probably just a Postgres or some NoSQL database. But what about the other data needs? There's more applications that will need fast in-app analytics, or they want to build some RAG solution. They can certainly do the search itself inside their operational database. But what about creating and chunking and do all the embeddings of all the documents before the vector search, and also do all the experiments with different models, different embedding, different chunking strategies. There's also the traditional data processing part. People need to process and clean the tables, and then somehow get the golden data set. Previously, it's only the big companies is doing that, but now every company kind of need to do it or every application kind of need to do it to be more intelligent. So at conclusion, people actually want a table, something can provide a one data model to ORM, or ideally there will be some kind of serverless execution, and hopefully that tightly coupled with their transactional data, so they don't need to move data around a lot. So to me, it sounds like a lakehouse might actually be what they need. Well, probably not today's lakehouse. Let's try to forget you are a data engineer, or forget you're a big data person. let's start like adopting a Lakehouse as a product engineer. So the first step is like I start to write Parquet files from my Postgres database. Oh, thanks for all the extensions. Like you can actually now directly write Parquet files. Previously, you probably need to actually write a CSV and convert it because like Postgres does not natively support exporting to Parquet. Cool. Next step is like you upload files to S3. Not too bad, but you at least like need to set up S3, set up like all the cloud related stuff. Then people will like do some search and then probably get like find PyIceberg or Delta Rust to start building some lake metadata on top of this like Parquet files. Seems like they want them to be filled as tables. Then they can finally got the table. Next step is to set up some like execution engine to query the table to use it. Or thanks to like technologies like DuckDB, people don't actually need to set up the Spark now, but that's a huge step forward. But then people start to realize it's not that fast. But more important is like it does not provide like too much functionality. The only thing you can do is like run like large queries. People would then soon realize, why don't I just go for a specialized database like Lakehouse? Why would I use Lakehouse at all? Well, hopefully he won't unfriend the data person who gives us a suggestion about building a Lakehouse with Delta or Iceberg. Cool. Now let's see how can we redefine the Lakehouse step by step to make it actually useful for like normal engineers, for product engineers, for like non-big enterprises, step by step. So the first step would be like, how can people get a Lakehouse with Lisp-pin? This is some work like we've been doing for the past few months. It's like open source projects. It's a Postgres extension. It's called PG Mooncake. So essentially the core of it is like you get a column store table in Postgres and the Delta and Iceberg table outside. How does that work? First, like think about like why people need like column store inside Postgres. Because like for the many years that people start like building like more functionalities on Postgres, like analytics is always like people tried a lot, but there's no like huge successes yet. It's partially because like in order to get like good like analytics performance in a database, you need like two things. One is like a column store storage format. The other part is a vectorized execution engine. Because like with a columnar format, you can like when scanning the full table, you don't need to like jump between rows. Instead, like when scanning a column, you just like only open that column and it's in a like very operation friendly format. And on top of that, with a vectorized execution engine, you can actually get the power of the column store format by operating on the encoded data directly to actually like get like 10x or 100x performance benefit. So people do want a column store inside Postgres to get like better performance. So how would we build one? We look at like all the successful like data warehouses right now. Essentially, the core of a column store table is like the column store files and some metadata on top of that to manage them into a table. So the easiest way is let's pick a column store format first. You can always pick a proprietary format, but nowadays like Parquet is kind of dominating the whole world and you want it to be open, so just go with Parquet. And then what about like the column store metadata? Essentially, the table itself is a list of Parquet files, so the metadata is going to be tracking like which files are currently part of the table. So when you insert, you add more Parquet files into the table. When you update or delete, you like remove some Parquet files from the table and add some new ones potentially. Okay, cool. Let's look at like how it's actually implemented. So in order to get like the Postgres like transactional consistency, everything should be in like somehow be tracked by the Red Hat log of Postgres. That's how we track like the metadata. So essentially, like all the list of package files, updates and deletes, or inserts will be tracked in a PG catalog table. So everything's like Red Hat log. But then like the actual data, the actual data files will be package files right directly to object store or like local disk. On top of that, in order to like get good performance, again, like a column store storage is not enough. You actually need a vectorized execution engine. And thanks for all the work in DuckDB Labs and like MotherDuck, like all the contribution from the community, we have DuckDB. It's like great like analytics in process database that's like provides us that like vectorized execution engine. So at its core, like PG Mooncake is like a 10 for column store table interface within Postgres. And also we implemented the storage extension for package files within DuckDB. So when the query goes into Postgres, when it sees there's a column store table, it will redirect that into DuckDB execution. And DuckDB execution will be able to recognize that table as well because we provided a storage extension that's like almost the same as a DuckDB native storage engine. So it supports like updates, deletes, inserts. Moreover, like with the help of PG DuckDB, you can also query the native like Postgres tables and do joins against them. Well, this is inside Postgres, but coming back to we are trying to build a lakehouse. So the beauty of this kind of design is within Postgres, you actually get a column store table, but this design, package with metadata, it's actually almost the same as all the leading lakehouse tables, no matter like whether it's Iceberg or Delta. So essentially, if you have package files in S3, it will be very cheap to just build some Iceberg or Delta metadata to turn them into a Delta and Iceberg table. Then this thing will be queryable by any engine outside Postgres as an Iceberg or Delta table, even if your Postgres itself is down. Again, here, like the table metadata inside Postgres need to be tracked by Red Hat log to ensure like all the Postgres transactional consistency. But asynchronously, you can very efficiently write those metadata as a Iceberg or Delta format. Okay, very cool. So with the Mooncake experience, like you just like have your Postgres and then add PG Mooncake to get fast analytics. But without like the product engineer ever realize it, they actually have the same tables as like Iceberg or Delta table. Then without them like realize it, have a lakehouse already. If they have data science or data engineers, they can just start querying those tables outside Postgres and do all the like machine learning or like BI workloads. Very cool. But this is like just getting a lakehouse. Remember like what our previous other question, lakehouse is not useful. So we really believe like you can get more workload coming to the lakehouse. The first part is like we are building the Mooncake indexes, essentially to serve apps directly from the lake. This is one pattern like we saw a lot in big enterprises. They have most of their data in like their Iceberg or Delta. But then they start to do some reverse ETL into either like a Pinecone, or Elastic, or like a Pinot, in order to like serve their actual applications. But when you actually look deep into the underlying storage of those systems, it's actually very similar. It's like there's not much difference between them and Iceberg or Delta. So why do they like duplicate those storage? It's because like people, in order to run like those special operations like search or point lookups or like fast aggregation, you need some kind of indexes. So Mooncake is trying to build like the indexes directly to the lakehouse, so they can either like directly serve those like vector search or point lookups, or they can like utilize those indexes in some other database or some other like execution engines, or directly using Postgres. Okay, this is cool, but this is something people can do right already today. What about something more like advanced or sounds like sci-fi? We also be looking into like what else can be stored in Lakehouse that does not make sense to store in any other format. We're actually doing some research with like LLM cache team from University of Chicago. Essentially, what they've been doing is like trying to extract internal states of large language models that could capture like your chat history, your long contacts, documents, the videos, like not the original documents, but like in the LLM internal state, like what's how LLM understands them. Those will be like hundreds of megabytes or gigabyte files. So like the only way to store them is to store in the lake. So, but with like Lakehouse, you actually want to like turn the raw files on S3 into something like more manageable and retrievable. This is what we've been trying. Essentially, like store and manage those like internal states of LLMs inside the Lakehouse, and then build vector indexes on them to directly retrieve and serve them into applications to build like a next generation of racks that can capture a lot more context and even faster, because like it avoids pre-filling the LLM with the documents you provide to them. Yeah, Mooncake is a research lab on the modern data lake, and we don't want to limit like what we build around the Lakehouse, but we really believe like it's possible to make it a lot more accessible to everyone and also a lot more useful. Thanks, everyone.